This video will guide you through section 1.4 and 1.5 notes. Make sure you get these sections into your table of contents, 1.4 polygons and 1.5 triangles. We'll begin with polygons, 1.4. Definition of a polygon: it's a closed figure that is formed by connecting line segments endpoint to endpoint. Here off to the left we see some polygons, and off to the right we see figures that are not polygons. This thing, for example, does not connect endpoint to endpoint, so therefore it's not a polygon. Likewise, that's not a closed figure. That's just an oval. You can't have rounded sides. Likewise, this thing is not a polygon because of that rounded side, which are not line segments. And then this figure is not a closed figure. You see it kind of crosses through itself. So some polygons that you probably already know: a three-sided polygon we call a triangle, obviously. A four-sided is a quadrilateral. Note that it's not a rectangle or a square. Those are special types of quadrilaterals. A pentagon, a hexagon, a heptagon. These, if you notice that the names 5, 6, and 7 follow the naming convention: pentagon, hexagon, something gon. And so if instead of a triangle you called it a trigon, that is a more correct name for a triangle, although nobody in practice uses trigon, but I just thought you might be interested. Likewise, a tetragon is the correct name for a quadrilateral, the correct Greek prefix. You may have heard septagon for a seven-sided shape, but that is actually, the nomenclature is wrong. So in addition to the 3, 4, 5, 6, 7, we've got these as well. We've octagon, nonagon, decagon, undecagon, and dodecagon. And I would like you to have the names through 12 sides in your memory. The 9-sided shape, there's also the Greek enneagon, which is more correct naming convention, although nonagon is typically more used in practice. And the polygons, without special names, we're just going to call n-gons. So for example, in this shape, we would call this a 13-gon because it has 13 sides. Next, I'd like you to draw yourself a pentagon. You'll notice that it's not a regular pentagon. Some of the sides are different lengths, and that's fine. Now I've given the points, the corners, I've given them label names. So this is either pentagon A, B, C, D. It would be a correct name for it. You could also call it pentagon B, A, E, D, C, sort of moving in the opposite direction, counterclockwise around the pentagon. You could not call it B, A, C, D, E, because that would not be following the order of the vertices. You always have to go in order, either clockwise or counterclockwise. So you could also have called this A, E, D, C, B, for example. Some more definitions. These would be considered consecutive angles, consecutive meaning right next door to each other or one right after the other. The corners are called vertexes, or better plural would be vertices. So point A would be one vertex. B and C would be consecutive vertices. And likewise, the side lengths CD and DE would be considered consecutive sides. Some more definitions: concave and convex. Convex polygon is one in which no diagonal is outside of the polygon. So here we have a convex quadrilateral. And concave is at least one of the diagonals is outside of the figure. So here we'd have a concave hexagon. Another definition: congruent polygons. We know that polygons are congruent when all the corresponding sides and corresponding angles are congruent. So here we have an example of all sides corresponding, congruent. Those tick marks indicate that. And then the angles as well. I've given the vertices some names, and note the congruence markings. Because all of the corresponding angles are congruent and all of the corresponding sides are congruent, we could say that camp is congruent to site. Sorry, bad joke. Next, some definitions with triangles, section 1.5. Right triangles have one right angle in them. Acute triangles have all three angles that are acute. and obtuse triangles have one obtuse angle. A scalene triangle has no sides congruent. An equilateral triangle has all three sides congruent. And an isosceles triangle has at least two congruent sides. So I'd like you to draw yourself an isosceles triangle now. We're going to label a few things. Here I have an isosceles triangle. It's tipped on its side, and that shouldn't freak you out too much. The vertex angle, the one off to the right, is the one that's made up of the congruent sides. The angles that are not the vertex are base angles. Right? The base is the side that might not be congruent to the other two congruent legs.